Hi folks, this is going to be a really quick one to look at the XYZ coordinate system. I've already done a video on getting ordered triples on the on a box, three-dimensional coordinate system, but I thought I would just go over it with the three planes, just to show you the three planes and how they connect to getting distances and ordered triples. Okay, so this is actually the first video that you'll watch. Alright, so what you see in front of you is just a box with the XYZ coordinate system. What we see is y being measured up and down, right? Oh, this is your origin, 0, 0, 0. Z is the distance coming out of the page. X is the distance going left and right, so right of the origin is positive. And as I said, y is going up and down. So kind of y and x kind of look the same as what they would on a piece of paper. Z comes out of the page. What I really want you to notice here it's important to be able to name each coordinate axis, but even the planes are really important. Okay, so let's look at this. So what plane is the blue one? Well, it's defined by x in one direction and y in the other. So this is called the xy plane. Right, and that's what you've been graphing on since grade 4 or grade 3. Okay, and on the xy plane, everywhere in that blue, z equals 0 because you haven't moved out of the page, right? That is like z's a distance out of the page. That is the page, if you will, or the screen, or whatever. So that's everywhere on the xy plane, z is worth 0. And it makes all of these values here 2 units away from, well, because each toothpick here in these diagrams is worth 2 units. So everywhere along here, which is parallel to the xy plane, those are all 2 units away, and so z is equal to 2 there. Alright, so what about the purplish one? Okay, what about this purplish rectangle? What is it? Well, it's defined by the y and the z plane. So that's the yz plane. A plane is just a sheet. Okay, the yz plane. Well, what is the x value everywhere on the yz plane? X equals 0 there. So if I'm looking at things, I'm just getting the x coordinate of any ordered triple. I have to look at the distance away from the yz plane. So this point right here, well, it's 2 units away. What about right here? It's 4 units away, right? Because it's the distance away from the yz plane. Okay, the shortest distance to the yz plane, a perpendicular distance. Finally, what's the one that's at the bottom of this? Well, it's the x-axis and the z-axis. So this is the xz plane. And what's the value of y on the xz plane? 0. So I only need compare to each plane. So if I want to know the value of y at any of the points, I just figure out its distance away from the xz plane. Okay, so that's going to be y equals 2 there, because each of the toothpicks is 2. So that point right there, what's the y value there? It's 1 because it's half of a toothpick above the xz plane. Okay, so really important to get your distances, you're comparing to the planes. All right, and that's it for that one. So hopefully that's going to help you in the next part. And I won't be referring to those planes very much in the next video. I kind of missequenced this, folks, so I should have done this one first. But anyway, nonetheless, I think it'll help. Oh, by the way, you can just see there's the XYZ coordinate system right there for this orientation. There are many different orientations that we can make work. Okay, so Z's going out of the page, X is left and right, and Y is up and down.